Okay, make sure you guys are writing this problem down because we'll be using this warm-up for our first practice problem, or the new thing that we're learning. So in this problem, it's asking us to find how many grams of LiOH you need to produce 1,000 milliliters of a 0.3 molarity LiOH solution. So basically, you're being asked to make a solution. So you're going to be making a solution, and you'll be doing the same thing in your lab. And then you're told this thing has to be 1,000 milliliters, and the concentration, so the strength of the solution, has to be 0.3 molarity. Basically, the question is asking you, how many grams of LiOH do you need to put in here in order to make this solution? Okay, so you're being asked pretty much to figure out how much you need to make this. All right, so let's go over the steps that we went over last time. So the first thing that you want to do is you want to take your milliliters and you want to turn it into liters. Okay, so if you guys remember, the way that you turn milliliters into liters is you want to divide by 1,000. So in this situation, 1,000 divided by 1,000, pretty easy. First step, you get 1 liter. All right, step 2 for the calculations is we want to use our molarity formula. So on your paper, just write down the molarity formula. Molarity is moles divided by liters. All right, guys, so let's start plugging in the numbers that we have into this equation. So let's take a look at what's given to us in the problem. If you guys take a look, the first number that we calculated in step 1 is 1 liter, right? And so if you take a look at the molarity formula, you see that there's liters on the bottom of the fraction. And so what we can do is we can plug in 1 liter on the bottom of our fraction. All right, the other number that we have in our problem is 0.3 molarity. And so what we're going to do is we're going to plug it in for molarity right here. So we're going to plug in 0.3 molarity, which means that what we are looking for in step 2 is we are looking for moles. Okay, guys, so for the calculations, you just multiply both sides by 1 liter in order to isolate moles. And so for our fraction, we will get 0.3 as our moles. And then just make sure you guys label this as the chemical that we're working with, so LiOH. So that's going to be step 2, finding moles of LiOH. All right, for the last step, for step 3, we are going to take the number that we got from step 2. So we're going to write down 0.3 moles of LiOH. And we are going to set up a fraction in order to convert it into what we are looking for. We're looking for grams of LiOH. So we are going to set up a fraction to turn this into grams of LiOH. And to do that, we're going to need to use the molar mass. So if you guys have your periodic tables, you guys can look that up right now. And I want you guys to see if you guys can use the periodic table to find the molar mass and complete this fraction. And see if you guys can get the final answer. I'll give you guys about 2 minutes to do that. Again, use the periodic table to find the molar mass of LiOH. See if you guys can plug it properly into this fraction and solve for grams. All right, guys, if you guys are still calculating, totally fine. But for the sake of time, I'm going to start going over the molar mass. So we're looking at LiOH. So on the periodic table, we're going to look at Li. Li is 6.94 for the molar mass, the number on the bottom. H is 1.01. And O is 16. So for LiOH, we'll do 6.94 plus 16 plus 1.01. And so the molar mass of LiOH is 23.95. So let's go to our notes again. And let's write down the molar mass. It's 23.95. And make sure you guys write grams equals 1 mole, because that'll tell us how to put it into the fraction properly. If you want to get rid of something on a fraction, you put the same thing on the bottom. So we're going to put moles on the bottom, and we put G on top because that's what we're looking for. Number next to moles is 1, so we put 1 mole on the bottom, and we're going to put 23.95 on the top because that's what's next to grams. The moles cancel out with one another, which leaves us grams. And so for our math, pretty simple. All we need to do is multiply the two numbers together. So we're going to do 0.3 times 23.95, and for our final answer, we will get 7.8 0.185 grams of LiOH. Alright, so that's pretty much it for the calculations. Any questions on that? Alright, so again, just to reiterate, the reason why we're doing this is we're trying to figure out how to make these specific types of solutions. So if you guys remember from the problem was pretty much saying, hey, I want you to make a 0.3 molarity solution. So you're trying to make a solution that's 0.3 molarity. That's the concentration or the strength. You want the size to be 1,000 milliliters. And what we're trying to figure out is how much LiOH to put into this solution to make it. And based on our calculations, you need 7.185 grams of LiOH in order to make this solution. Okay, so what we did was we figured out how much LiOH we need in order to make the solution that it's asking us to find. And that's what I'll be doing in our lab coming up. I'm going to be telling you guys, I want this size and this strength of a solution. How are you going to make it? And this is how you calculate that out. Okay. Today we're going to be learning how to write the procedure. So basically, you're going to be learning how to write the steps in order to make these solutions. So when you're in a lab, what steps are you going to take? What equipment are you going to use in order to make these solutions? And luckily, it's pretty simple. Every time you make these solutions, it's the same general steps. The only thing that really changes are the numbers and the chemicals that we are working with. So I'm going to scroll down now. Okay, and there are going to be 5 steps that we are going to take in order to make the solution. Okay, and I want you guys to copy this down, and I'll tell you guys which parts to copy down, which parts not to. Okay, so step 1, you want to obtain a volumetric flask with the appropriate size. For on your notes, I want you to write step 1, and for step 1, you're just going to write obtain and I want you to write blank milliliter volumetric flask. And I'll show you guys what a volumetric flask is and what all these things look like in real life. But for now, just write step 1. You want to obtain a blank milliliter volumetric flask. So again, the volumetric flask, the size is going to depend on whatever amount of solution you want to make. Okay. All right, let's go to step 2. Step 2 is where you weigh it out on a scale, the amount of the chemical you need. So we're going to write, you're going to weigh out. And in this situation, in the problem that we did previously, this is where we put the number that we calculated. We're going to weigh out 7.185 grams of LiOH. Okay, so all the math that we did was pretty much to figure out how much solute you need to weigh out. And so this is the step where you write down how much you weigh out. Okay, so again, step 2 is where you weigh out the amount of solute that you need in order to make that solution. Okay. All right, step 3 is pretty simple. You are going to add whatever chemical you're working with. So you weighed out 7.185 grams of LiOH. You're going to add the LiOH into the flask using a funnel. And so if you guys notice, the flask has a pretty skinny neck where you put stuff in. And so we're going to use a funnel in order to pour the compound into the flask. Okay, so that's step 3. You're going to use a funnel in order to add your chemical into the volumetric flask. All right, let's go to step 4. For step 4, you're going to add water. So basically what we did in steps 1 and 2, or step 1, we got the flask. So this is our flask. Step 2, what we did was we added the chemical in there, right? So we added the solid chemical in there. That's step 2 and 3. And then what we're going to do in step 4 is we're going to add water into the chemical. Now, if you're holding the flask, I want you to look at the skinny part. And if you look at the skinny part, there's actually a line on the flask. Okay? That line right there is going to tell you when you have reached the volume that's written on your flask. So if the flask says 1,000 milliliters, if you pour water until you get to that line, that's going to be when you guys reach 1,000 milliliters. If you're done with that, you can just leave it there. I'll pick it up. Okay, so you're going to add water until it reaches that line. And then after that, step 5 is pretty much you're going to stir until everything is dissolved. Alrighty, guys. So I got the answer up there for you for the calculations. Pretty much same 3 steps that we did in the warm-up. You should end up with 189.88 grams of CaBr2. And then, like I said earlier, you need to write the 5 steps. If you guys don't have the 5 steps on your assignment, you will not get credit for it. So I know it's a lot of writing. If you want to type up the steps, you can. Just make sure you guys put the picture of your work on your assignment on Canvas, and I'm totally cool with that as well. But you guys do need to have the 5 steps for all the problems on your assignment. Okay?